So today we're going to walk you through some basic forensic analysis of a USB thumb drive. The case is pretty contrived, but to show some clear illustrative examples of how to use the tools and practices, this makes the most sense. First, you'll notice I've already got my forensics drive mounted, thumb drive E, and to build the test set, I'm going to add some files to this drive. Now, I've already put the files together for the drive. You'll see the names listed here. We're basically just going to copy this over to the drive. Prior to this, I have done a secure wipe on the drive, which essentially writes a series of ones or zeros to the drive to clean up any old ghost images, so that hopefully we'll have a purely clear drive with just the information that we're adding and deleting now. So if we go over to our forensics drive, we'll see that we have the files that we just created. The first thing we're going to do as part of this case is to show this Excel file. And I'm going to go in and, for the sake of argument, put a fairly weak password on here. TAP. I'll explain why I'm using a relatively weak password later for this illustration. And you can see this was basically a set of pickup times for delivery, let's say a drug dealer, and the passphrase that they would use when they met. Again, it's fairly contrived, but gives a good example of the kind of data that could be stored here. Now we've also got a series of Word documents in here, generated with lorem ipsum. You'll see it looks like a bunch of gibberish. It's because it is. But let's suppose that someone went into the middle of all this text and wrote And additionally, let's suppose they decided that the contents of deleted document 1 were too sensitive to have anyone see. So I'm just going to delete this document from the thumb drive. And also a note that I created a document here whose file extension I've changed to JPEG, but it's really the Word doc. So you'll notice that when I try to open it, it won't work because it's trying to open based on the extension, and we'll walk through how to fix that without the advanced knowledge that we have now. Alright, so that's basically how we're going to build the test case.
We're going to verify that our USB ports are write protected. In order to do this, you launch regedit, open up the registry on a Windows system. The path is HKey local machine, system, current control set, control. Verify that you have the key storage device policy. And the D word inside is write protect set to 1, meaning that the USB ports will be write protected.
So now that we've built our USB thumb drive image and we've write protected the disk, the first basic step in forensics analysis is to create an image of the disk so that we can do the analysis on the image and not threaten the contents of the original disk. I'm using a tool called ProDiscover Basic. There are multiple tools you can use. In Unix, you can use DD. In Windows, you can use ProDiscover or other packages like FTK Imager. In ProDiscover, First, we're going to create a simple project. The information here is arbitrary, but you'd want to probably use a naming convention to catalog your investigations. So we'll create a new project, and then we'll tell it we want to capture the image. I'm going to select our thumb drive, E. I'm going to tell it to use a standard Unix style DD format because a lot of different tools are capable of reading that format. And then I'm going to select a directory. For this case, I'm just going to put it on my desktop. Verify the name, and then I'm going to say OK. Now, this warning you can kind of ignore because we don't need all that additional information. All we're really trying to do is create an exact forensic copy of the image. And this will take a few minutes depending on the size of your drive. So we'll record it and come back to the analysis after. For the next part of our forensic analysis, we're going to import the image file into a well-known tool called Autopsy. As you can see, it's available here at sleuthkit.org, and it can read a standard DD file and do a variety of analysis on the drive image. Even though there's a lot of different versions depending on the operating system you're on, the basic functionality is the same across the versions. So first thing we're going to do is create a new case. Again, this information is arbitrary, but should be used to index your different investigations. Just going to create a fake case number here and use our class ID as the examiner name. So the first thing you need to do is add a data source for the tool to be able to analyze. In our case, we're going to use an image file, which is a DD file. And I named it thumbdrive.dd. There's a variety of parsers and plugins that Autopsy leverages. We're just going to choose all of the options that are available in the version I have installed. And then when we're done, we're going to say finish, and it'll go ahead and ingest all that data into the current case.
When we imported our image into Autopsy, Autopsy noticed right away that there was an extension mismatch. So what we're going to do is we're going to export that file twice, once with the extension .jpg and again with the extension .doc for a Windows document file. Once the images have been exported, what we're going to do is we're going to do a file checksum integrity on both of the files to verify that they've remained the same for their hash values during the export, and to verify from that point against a rainbow table. So there are two files that are exported. We're going to launch a command prompt. This command, FCIV, stands for File Checksum Integrity Verifier. This is a download from Microsoft if it's not part of your operating system. You can download it, extract it to your System32 so it launches through command prompt. So what we're going to do is give it its path because we want to check the MD5 and the SHA-1 integrity of both of the files. So once we give it its path and we launch it, it shows us the value of both of the hashing for the .jpg. We're going to do this again for the .doc file and verify the file has remained the same with the file extension and the export. Now we're going to check our hex signature value of the file that's in Autopsy based against known good hex signatures. So we've got the Wikipedia. This is a list of known good hex signatures. We scroll down until we find the signature for office documents. We found it here. And if we compare that signature back in Autopsy, we see that it matches.
Now that Autopsy has ingested the current drive image, let's take a quick look at a common task, which is recovering a deleted file. Under the data sources folder, you'll see the thumb drive data source that we just imported. I'll select that. And now in the directory listing drive, we can see all of the files and folders that it was able to recover from the bit copy. One thing we'll notice is this particular file called deleteddocument1.doc. And I will take a look at that really quickly using the built-in tabs. I can see the hex values. I'll notice some built-in text. I can see the lorem ipsum text here. If this is an actual file, I could probably see some of the meaningful text here and determine if this is something that I wanted to recover. So in this case, we'll say good. We'll recover the file. We'll right-click on the file name and say extract files and select a folder and a file name. In this case, I've already extracted it once, so I'll have to write over the existing file. And as you can see, the file is extracted. Now if I go to my Windows Explorer and I look in the folder where my Autopsy case is saved, thumb drive analysis, there will be a folder called export, and in that folder you'll see any of the documents that you've extracted. I can double click on the document now. In this case, it wasn't able to create an exact copy of the deleted image, so I'm going to just tell it to use Windows default encoding. And as you can see, most of the text from the original document is still available, even though the encoding has changed some of the formatting and added some unreadable text. So if you needed to find specific text in this document, you would still be able to get to it with a little searching. And that's how you'd recover and examine a deleted file. In this section, I'm going to briefly discuss steganography. Steganography is the practice of concealing messages or information within other non-secret text or data. In this case, we're going to talk about the ability to hide a message inside an image file. The practice basically allows you to put a message inside a standard image file without the outward appearance of the picture looking any different. So to the casual observer, they wouldn't be able to tell that there was a message embedded in the file. If we go back to our drive image, we'll see multiple pictures on the drive. Most of them seem unremarkable. And then we'll notice two that look identical. And that might give us a clue to think that something had been tampered with. So the first thing we'll do is extract those files out to our drive. And we'll override them if they already exist. And in this case, I have some foreknowledge that these are created with the QuickStego package. And just to illustrate how even those images looked exactly the same, one of them would have information inside it. We'll open the JPEG first. And you'll notice that QuickStego tells us that there is no secret text message created with QuickStego in this file. Now we'll open the other image. And you'll see this is a test message to show hiding the text. And this is how steganography can be used to hide text in images for sharing secretly. So the casual observer is unable to detect the information being passed. Now we're going to talk quickly about another scenario that you might encounter, and that's a locked Excel spreadsheet or another locked Office document. In this case, the spreadsheet that we locked earlier. First thing we need to do is extract the file out to our disk for analysis, and we'll save it to our standard export folder. The next thing we're going to do is pull up our favorite cracking software. And this could vary by version. In some of the older versions of Excel, there's easier ways to do this. This happens to be an Excel 2016 document. I'm going to use PDS Excel Password Recovery. Now, there's a couple ways that these recovery or attack packages work. One is using a dictionary of words that it can iterate through, and the other one is brute force, which basically tries every possible combination. And these can take a really long time to execute, since it's essentially trying every possible word combination that it can come up with in the constraints that you've provided. In this case, I'm going to set it to the size that I happen to know the password is, just for demonstration purposes. I'm going to use a brute force attack, and I'm going to tell it to recover the password. And as you can see, it's going to iterate through every possible combination that it can find in that space. I'm going to let this run, and we'll see what it looks like in a while. Now, the program ran for roughly 30 minutes, and you can see that it has determined that the password for the file was tap. This is a relatively simple example, and I'm running it on a relatively slow computer. You'd probably want a lot more horsepower if this is the kind of attack that you're going to do to recover a password on a file. So let's go over to our file. Type in the suggested password, tap, and now we can get in and see the contents of the file. One final important aspect of any good forensics tool is a search. So quickly, let's look for that commons that I put in the middle of that gibberish lorem ipsum word doc earlier. Do a quick search, and Autopsy quickly discovers that it's in document2.doc. And in the index text area here, I can see me, you at 1230 at the commons. So if I were looking for someone's name or an address, I could quickly find any documents that had that information in it. Thanks for watching our video. We hope you found it educational.